Right, this lesson, we are moving on to partial fractions, integrating partial fractions. This, on its own, partial fractions is not a difficult thing to do because you should have done this in Pure 2, Chapter 1 about partial fractions. The difficult things lies in when you split them into partial fractions, what to do afterwards. So partial fraction is just the first step, but what's after, that's more important. All right, so when to split into partial fractions, when the question tells you to, just kidding. Usually when it comes to partial fractions, some nicer questions will give you a part A, which is asking you to split into partial fractions as a hint to tell you, okay, you must do partial fraction first before you do integration. But in here, these questions, we assume they did not tell you and you have to recognize it in the first place, right? So, well, when bottom denominator has the same or larger power than numerator, then we know we have split into partial fractions. Or more importantly, if the denominator, if denominator is a product of more than one factors. So what we mean by that is, for example, if you look at the example in here, x squared minus 1, straight away you should notice this is a difference of 2 squared, x minus 1, x plus 1. Then you can see this is a product of more than one factor, two factors. Okay, so we know we're splitting the partial fraction. That's a big cue for you to understand this is a partial fractions. So first of all, we need to do partial fractions first. So partial fractions. As I said, some nicer question will tell you, okay, part A, do partial fractions. They give it to you, but some of them not so good ones, you have to do it manually yourself. So a over x minus 1 plus b over x plus 1. Now, use this as a template. Pause the video, have a go at, as a partial fraction, treat it like a revision, have a go at the question. When you're ready for the answer for a and b, the values a and b, you can press play. So here's the answer of the partial fraction you should get when you start in x equals 1, you should get a equals 1, and b, when you start x equals minus 1, you should get b equals minus 1. But be mindful, some of you might have done x plus 1 in the first fraction, then your a will be the value of b, which is minus 1, and your b value will be the a value, which is 1. Make sure you keep the denominator the same as your values of a and b's. Now, one thing, when you have b is minus 1 in here, I don't put a minus 1 numerator. Instead, what I do is I change the plus into minus, because when I integrate, so I'm just missing differentiation. Differentiation has been a good friend, but now comes integration, which is not so good as a friend. Quite horrible instead. So what we're doing here is when you have a minus in here, then when we integrate, we don't have to care about the minus. We can sort it out later. So what we've done in here is once we're split into partial fractions, nice, we rewrite it, okay, in here. Then what do we do? Okay, middle step, you can write it one by one if you want to. Okay, but it's not it's optional. Next, okay, remember what we talked about last lesson, or if you don't know before, I did mention a skill that we use, which is called RTSP. This is your chain of thoughts, what you should be thinking when it comes to integration, any expressions. First thing that come to mind is about RCR, RTSP, R, reverse chain rule. Now, in the reverse chain rule, there's one more thing. When it comes to reverse chain rule in a fraction, okay, you should think about LPP. L stands for ln, P stands for power, and last one, what does this one P stand for? LPP. Oh, we'll come back to it. I can't remember now, but I remember using LPP. We'll come back to this at some point. LPP, or if not, just write LP for now. ln or power. Oh, I remember this, partial fractions. Sorry, partial fractions. Yes, that's what we did today, partial fractions. So when you see a fraction, okay, using reverse chain rule, so LPP. In here, do we need partial? So we think about ln first, okay? We think about ln. If we can't, then we think of power, and then we think about partial fractions. So let's have a look again. In this question that we're just looking at, in here, okay, if we have to use reverse chain rule, this is a fraction, so we should be thinking about ln. Does ln work? It will work in here. So we let y to be ln x minus 1. Now, hopefully you remember the reverse chain rule from chapter 11.2. And hence I stress so much so much that reverse chain rule is the #1 biggest enemy or friend, depends how you say it, in integration. So it's a love and hate relationship. You love reverse chain rule because it works in a lot of situations, but you hate it because it's not as obvious. So let y equal, so we differentiate to verify that. Differentiate is 1 over, is differentiate ln is 1 over x minus 1, differentiate inside is 1, so it's 1 over x minus 1. It works, the algebra works completely the same, so I know the integral of the first part is just the y ln x minus 1. We usually put a modular sign. We can put a bracket, but modular sign will be more technically correct. Next one, what about this one? We do the same thing in here, reverse chain rule. So we let y equals ln x plus 1, differentiate dy by dx, differentiate that one is 1 over x plus 1, times by x is 1, so it works. So then we know it's a minus, so the integral of 1 over x plus 1 is just ln x plus 1. And then we have our plus c. So as I said, it is not, the partial fraction is not the biggest enemy in here. It is the what to do after the partial fraction individually for each fraction. Now, if you're familiar with the reverse chain rule in here, as you will do partial fractions more, you will see these type of fractions a bit more frequently. And in your head, you probably can do this reverse chain rule manually in your head. If you can do this in your head, you don't have to show this working out. This working out just to show you how reverse chain rule works. Okay, why the integral of 1 over x minus 1 is ln x minus 1. Okay, if you want to verify that, you can always differentiate and see if you get it back into the original expression. These steps are optional, but as to start with, I will always suggest you to write them out, okay, just to tell yourself how to work it out. Plus C, can we simplify things in here? Yes, we can, because ln A minus ln B, we know our log rules, which is ln A over B. We have our plus C, and that's the final answer, right? Next example in here. Find x minus 5. So what I would ask you to do is, can I ask you first to do the partial fractions? We can see a product in the denominator. So a over x plus 1 plus b over x minus 2. Pause the video, have a go at the partial fractions. When you're ready for the answer, then rewrite the integral with the new partial fractions, and you can press play. Yeah. So here's the answer. You should get a equals 2 and b equals minus 1. Again, I didn't put the minus 1 in the numerator. I put the minus 1 in the front, put the minus in the front. Okay. So in here, what can I do? I'm going to split the fraction again. But also this time, you can see the first fraction, there's a 2. 2 is a coefficient. I'm going to put it outside of the integral sign. So it'll be 2 integral x plus 1 dx minus integral of 1 over x minus 2 dx. I've mentioned this a lot of times. Why do I put out a coefficient? The reason being is I put it out is so that I can just focus on integrating this and nothing to do with the 2. The 2 is just a 2 times whatever I've done with the integral. Okay, so it's like compartmentalize our brain to help us think chunk by chunk. We can ignore the 2 in here. So now integrate 1 over x plus 1. Reverse chain rule. Okay, reverse chain rule. I'm going to let y to be ln x plus 1 because I know differentiate ln will give me 1 over. So dy by dx, and it didn't disappoint. 1 over x plus 1. Differentiate inside is 1. So I know the integral is matching completely with the question. So equals to 2 of the y answer. What I guessed, ln x plus 1. What about the second one? Well, reverse chain rule again. Let y to be ln x minus 2. Differentiate it is 1 over x minus 2. Differentiate inside is 1. So 1 over x minus 2 is the same as the question. So the integral is minus my guess answer, which is ln x minus 2 plus c. Now this all reverse chain rule. I'm skipping quite fast in here. Is not skipping, but doing quite fast is because I would assume you should be quite familiar with reverse chain rule. If you're struggling to keep up with the pace in the reverse chain rule, I suggest you pause the video now, have a go at some questions, reverse chain rule again, or look through the notes again, just to get yourself up to speed about reverse chain rule. Up to speed, pace, oh, pun intended. Well, not intentional, but there we go. So what can we simplify in here? Well, we see some ln's where you can put the power. So ln x plus 1 squared minus ln x minus 2 plus c. Ln a minus ln b equals ln a over b plus our darling child, the missing child, forgotten child, plus c. That's the final answer. Next one. Okay, next one. Example, one more. Okay, this time I'm not gonna help you break down the partial fraction. See if you can break it down the partial fraction on your own first. Okay, so pause the video, have a go at the partial fractions. When you're ready for the answer for the partial fractions only, you can press play. Right, so here are the answers for partial fractions. Just one thing, make sure you remember when you have a square, double root, repeated root, you must have split into two fractions. Okay, one with the power of 1, one with the power of 2. Now, if you split in a different way, where you put x minus 2 first, make sure you're matching my letters. Make sure you have these numbers, but whichever one you put in first, you should get all of these fractions, but it might be in different order. Okay, so but if you've got different order, if you've got wrong, try in my one and on a separate piece of paper and see if you get that. If you got that, just copy my answer in here. Okay. Next, so what do? Again, we've got 3 fractions, so we can split them into 1 by 1. Okay, let's split them into 1 by 1. So the first fraction, I can pull out 2. So with 2, and then pull out coefficient, and 1 over 2x plus 1 dx, plus next one, I can pull out 3, x minus 2 dx, and the last one, pull out negative. Right. So 1 by 1. Now this time we are going to reverse chain 1 by 1. Reverse chain rule. So I'm going to let y to be ln 2x plus 1. Let's differentiate dy by dx, which is 1 over 2x plus 1. And then I need to differentiate inside, which is 2. So 2 over 2x plus 1. But I checked with the original function here. It was a 2 compared to 1. So therefore, I need to multiply the final answer by a half of the y value. So it will be equals to 2 times on the outside, 2 times, because the 2 on the outside, times a half, because I'm comparing the 2 with the 1 of my y function of my ln 2x plus 1. Okay, so that's the first function done, completed. Second one, what about this one? Reverse chain rule again. Let y to be ln x minus 2. Let's differentiate. That's 1 over x minus 2 times 1. So it's 1 over x minus 2. It's matching, so this one is matching, so I don't need to do any balancing. So my integral will be, so there was a plus 3 in the front, so it'll be a plus 3 in the front, times the integral, which is our guess answer, ln x minus 2. Now, last but not least, okay, now do not write anything here for the last one. Okay, so let's try reverse chain rule in here. Let's try ln as we have done previously. Let's y equals ln what x minus 2 squared. That's a bit weird. You can tell it looks a bit weird by now already. Let's try differentiate. Okay, so ln of x minus 2 squared. Ln is the far one outside. So dy by dx equals 1 over chain rule. Differentiate outside. Okay, 2 times inside. Differentiate power of 2 is 2 bracket x minus 2 to the power of 1. So my final answer will be 2x minus 2 over x minus 2 squared. Now you tell me, does it work? It doesn't, because if I simplify it, x minus 2 to the power, you can see the algebra is not matching. What's not matching? Well, reverse chain rule doesn't work when the algebra term does not match. For example, in here in denominator, there was a power of 2, but there was only power of 1 in here after we simplify it. Or if you don't want to simplify, power of 1, you can see there was x minus 2 in numerator, but there's no x minus 2 in numerator. That's when we mentioned about the algebra does not match. The algebra terms must match perfectly. The numbers do not have to, the coefficients do not have to, but the algebra must be. So in this case, we know reverse chain rule using ln does not work. Okay? If you want to write this down, pause the video and write it down as to yourself why ln doesn't work. Okay? So we're going through the correct one. Okay? So if reverse chain rule using ln doesn't work, what else can we do in here? Well, I mentioned about this. When you see a fraction, we'll do LPP. L is ln, the next one is a power. Okay, so we can look at the power. So what's the power? Now, this could be written as, you can see, it's x minus 2 to the power minus a half. Sorry, minus 2. So we can rewrite that as an intermediate step for now into minus the integral of x minus 2 to the power minus 2 dx. Now this works. So the next one considered as a power, it's the -2. So if we do reverse chain rule in here, we can let y to be x minus 2 to the power of minus 1, because differentiating power of minus 1 will give you power of minus 2. So dy by dx minus 1, differentiate the power first, minus 2, times differentiate inside is 1. So that's minus x minus 2 to the power of minus 2. Compare this to the original question. Now, the minus in here, we're not counting this minus outside the integral sign. We're only comparing what's inside the integral sign. So there is no minus in here. In other words, we have to balance with a negative of our y value. So this is what the final answer looks like. So we've got in here, we can simplify things. 2 and 2 give us ln 2x plus 1 plus 3 ln x minus 2 minus, so that's minus, and then when we integrate, the integral is negative x minus 2 to the power minus 1 with plus c. Right? So I'll explain again. The last part is probably confusing. This is just a reverse chain rule question. In order to differentiate, give a power of minus 2, we'll be thinking about a power of minus 1, because power of minus 1 will differentiate with power of minus 2. So that's normal reverse chain rule. Then you compare this algebra term with what's in the question. There was no minus, so answer will have to be the negative of the y function, the negative of x minus 2 to the power of minus 1. What about this minus? This minus was from the outside. Okay, so we are compartmentalize what we're doing in here. The minus has nothing to do with it, so we'll leave it outside. Put a bracket. There was a minus in there, so we'll integrate, and it's minus. Okay, so I just have to simplify things a little bit. There are things I can simplify or not. You can in here if you really want to, but I'm going to keep it like this. So x plus 1 plus 3 ln x minus 2. If you do want to simplify, you can put a power. You can put a 3 in the power like this, and then do log a plus log b, and minus makes a plus. So if you really want to, you can do ln 2x plus 1 x minus 2 cubed plus x minus 2 to the power of minus 1 plus c. Now, the reason I didn't do, I say you could rather than you should, is because this term, there's no ln in there. So I know it could not be simplified together. So there's really no point to put them together now. But anyway, that's a different question if we have to simplify it any further. But in terms of differentiation, integration, it's quite monstrous in here. Reverse chain rule, when denominator is a nice fraction, okay, to the power of 1, then ln quite easily. But when the denominator is a square on the outside, you should consider the negative power, and hence LPP in the reverse chain rule. L is ln. First chain of thought is ln. And then if you see negative power, think about the negative power. Okay, if you see a power in there, think about negative power, and then go from there. Okay, this all comes from practice. It sounds quite difficult in here, but as you do more practice, you get used to it. Okay. Right, then here you go. There's an exam question for you to try. Okay, pause the video, have a go at question A first, because if you don't get question A correct, I'll give you the answer for A and then move on to B. So pause the video, have a go A first. When you're done for the answer in A, you can press play. So these are the values for A, B, and C. A is 4, B is -3, and C is 1. If you got it right, well done. Then move on to part B. Okay, part B first, because if you mess up part B, again, you mess up part C. So if we go part B first. If you got it wrong, try again. When you're ready for the answer for part BI, okay, you can play the video. This is the answer for part BI. Okay, you could be doing something different by simplifying, by putting as a square as a power of 3, but this is what the mark scheme says you need in order to get 3 marks. If you got it wrong, if you got first one, if you got it right, well done. Move on to part 2, okay, where you find the value of k. But if you got it wrong, I'm going to go through step by step. How do we do that? So first of all, I'm going to rewrite it as 4 over 2x plus 1, and then dx. Oh, actually, not dx. 4 over 2x plus 1 minus 3 over x plus 1 plus 1 over x plus 3 dx. And I can bring the coefficient out. 1 over 2x plus 1, split 1 by 1, minus 3, integral 1 over x plus 1 plus 1 over x plus 3 dx. So 1 by 1, the first one, I can do reverse chain rule in here, reverse chain rule. I let y to be ln, denominator, 2x plus 1. Let's differentiate that, which is 1 over 2x plus 1. Differentiate ln is 1 over. Differentiate inside is a 2. So that's 2 over 2x plus 1. I compare with the question, it's only a 1 in there. So what it means is I have to multiply by a half in order to get to the original function. So it times by a half. Therefore, my answer will be, my integral will be 4 on the outside times a half of the y function ln 2x plus 1. Second function, reverse chain rule again, we let y to be ln x plus 1 dy by dx. So it is 1 over x plus 1. That's exactly the same as the original function. So minus 3 times my guessed answer, ln x plus 1. The last one, same, is ln x plus 3. So plus ln x plus 3. And don't forget the child, plus c. So 4 times a half is 2, 2 ln 2x plus 1 minus 3 ln x plus 1 plus ln x plus 3 plus c. That's the final answer. Okay, so you should pause the video and have a go at part 2. Okay, when you're ready for the answer, you can press play. This is the final answer. Part B2, K is 125 over 81. Okay, if you got it right, well done. Then we can move on to, there's one more part, move on to one more part about the example, a top-heavy fraction. But if we got wrong, we'll have a look how. Okay, so this is more about substituting numbers and deal with the log, deal with ln. It's more of a logarithm question rather than integration. So let's deal with that. Okay, so we need to put a 2 and a 1 in there. The question needs to put a so 2 ln 2x plus 1 minus 3 ln x plus 1 plus ln x plus 3, 2 and 0. So let's put a 2 in there. So if we put a 2, we'll get 2 ln, 2 times 2 plus 1 is 5, minus 3 times ln, 2 plus 1 is 3, plus ln 5, put a bracket, minus, put a 0 in. Okay, so when I sub in 0, 2 ln, 2 times 0 is 0, plus 1 is 1, minus 3 times ln 1, plus ln 0 plus 3 is 3. ln 1 is 0, so that's gone, that's gone. So next, I can simplify things a little bit. 2 ln 5 plus ln 5 is same as 3 lots of ln 5, minus 3 ln 3, minus ln 3. Next, what can I see in here? I can expand the bracket without, rewrite without the bracket. Okay. Next, the different things you can do, you can either put them all in the power and do log rules, log A divided by B divided by C, or in here, I see a, oh, why don't we do that? So bring in the power, ln 5 cubed minus ln 3 cubed minus ln 3. That might explain a bit better. ln 5 cubed is 125 minus ln 27 minus ln 3. So how it does is we can do ln A minus ln B is ln A over B. And then we can do the same again. So it's ln 125 over 27 divided by 3, which is same as ln 125 over 81. Okay. Right. One more example. Okay, one more. So what happens if we have to do, we've got a partial, we've got a top-heavy fraction. Top-heavy fraction means we have to do algebraic division first. Is this all about partial fraction knowledge? So we have to do algebraic division. So how do we do that? We do x squared divided by x plus 1. We're going to fill in the gaps with plus 0x and plus 0. So to match an x and x squared, we need to multiply by x. So x times x is x squared, x times 1 is x. Do a subtraction, that's a minus x plus 0. To get an x to a minus x, and you multiply by minus 1. So minus x minus 1. There will be a remainder. 0 minus minus 1 is plus 1. So how do we write that? Well, hopefully you remember that if I want to do 64 divided by 9, I can do 9 times 7, which is 63, remainder 1. That means 64 divided by 9 can be rewritten as 7 plus 1/9. 7 plus 1/9. So we're going to do that. So it means the integral of x squared over x plus 1 dx can be rewritten as what's on the top, x minus 1, plus the remainder over the divisor, x plus 1 dx. That's just like what we did with numbers. Okay. Now then it becomes something we can easily integrate. We can integrate x, which is x squared. We can integrate 1 minus x. This one is ln x plus 1 plus c. That's the final answer. Okay. Quick reminder, what's a top-heavy fraction again, just in case you forget? Top-heavy fraction means if the numerator power is bigger or equal to denominator. So if you look at this, the power in numerator is 2, compared to denominator is 1. 2 is bigger than 1, this top-heavy. However, if the denominator is also 2, it's also a top-heavy, okay? If it's 2 and 2 is also top-heavy. What's not top-heavy is when the numerator, the power is smaller than the denominator. For example, x over x squared plus 1, then that's not top-heavy. Okay, so hopefully that reminds you everything about the partial fraction. Last but not least, practice question, okay? Pause the video, have a go at the question. Now I'll give you the division in here because I want to make sure you know how to do division here. 0x plus 2, x plus 1. Pause the video, have a go at this division. Once you've done your division, okay, and rewrite that like what I did in at this step, then you can press play. Okay, so rewrite that, just do division first, because if we got division wrong, there's no point doing anything further. Okay, pause the video and have a go. That should be your division. Okay, x squared minus x plus 1 is your quotient in here. Okay, so we can rewrite that as integral of x cubed plus 2 over x plus 1 dx as the integral of x squared minus x plus 1 over x plus 1 dx. To integrate x squared, you can pause the video and finish up a question. Okay, when you're ready for the answer, you can press play. And here's the final answer, just a one-liner. X cubed over 3 minus x squared plus x, and then to integrate 1 over x plus 1 is ln x plus 1. And don't forget the child, plus c. And that's the end of this lesson.